video, we're going to discuss the Pythagorean Theorem. The Pythagorean Theorem can only be used on right triangles. The two sides that touch the right angle we call the legs. The side across from the right angle, or the longest side, is called the hypotenuse. And what Pythagoras discovered, he existed like 500 BC, that's a long time ago, but his discovery has lasted the test of time, I guess. He said that the leg squared plus the other leg squared always will equal the hypotenuse squared. But that became wordy, so he just called those two legs, the ones touching or hugging the right angle, A and B. And he called that hypotenuse, that longest side across from the right angle, C. And it's become known as A squared plus B squared equals C squared. We're going to look at two examples. One where a right triangle is missing the hypotenuse. So the side across from the right angle is the unknown, where the two touching the right angle, or the legs, are known. So let's start. We first start by writing A squared plus B squared equals C squared. Remember, the legs are the A and the B, in this case the 2 and the 4. It's that C that's unknown. We square, giving us 4 plus 16, we add, and then to undo that squaring, we take the square root of both sides. Our answers are usually required to be simplified, so we look for a perfect square hiding out in 20, and we discovered that 4 goes in there 5 times, and we know the square root of 4 is exactly 2. We don't know the square root of 5. It goes on forever and never repeats. So we say that our simplified answer for x, the length of the hypotenuse, is 2 times the square root of 5. For our next example, we're going to be missing a length on a leg. So again, this only works for right triangles. This time, we have a 6, a 3, and an unknown. Remember, the legs hug that right angle. So x is a missing leg. The hypotenuse is the longest side across from the right angle, and we know that this time. So again, we start with our theorem, A squared plus B squared equals C squared. It's very important that that C gets put in on the right side of the equals. And the C in this case across from that right angle is 6. The A and the B can be interchanged. So we could do 3 squared plus x squared, or we could do x squared plus 3 squared, because we're just adding, so the order doesn't matter. But that C's got to go in on the right-hand side. Then, like on the last time, we square our numbers, and we're trying to solve this for x, which means we need to do a couple inverse operations. We need to subtract 9 to get the 9 off the left-hand side. That'll give us x squared equals 27. And again, to undo the squaring, which happens on every Pythagorean theorem problem, it ends in taking a square root of both sides. We end up with x is equal to, the perfect square was hiding in 27 on 9. So we end up with x equals root 9, root 3. So the root 9 is exactly 3, but the square root of 3 goes on forever and never repeats itself. So our missing leg length is 3 times the square root of 3.